Already forgotten. Okay, so we'll start with number 1 on the section 5.3. You were solving these trig equations. And on this one, they're actually just telling you to verify that these are solutions. So the first one is x equal pi thirds. And the second solution is x equal 5 pi over 3. And one thing I'm going to go ahead and write on my paper here is I'm going to go ahead and draw that little mini coordinate graph and put all students take calculus, because probably if this one's a solution, if it's positive, where the cosine is positive is going to give us the other solution, so that's how we could quickly tell if it's a solution or not. Okay, so what we're trying to do is get the trig function by itself on one side. So I'm going to circle cosine x, okay? If I can get that by itself on one side and get everything else on the other side, then I can just figure out what angle I'm talking about. It becomes like other problems we've done. So it's just algebra, really, moving terms around. So I would add 1 to the other side first, just to move it over. And then I'd have 2 cosine x is equal to 1. And then I would divide both sides by 2, just because I'm trying to get cosine x by itself. So I get cosine x is a half. Now, sometimes we draw all of our triangles, special triangles, but then there's that other thing that we've done too, some that's also helpful, is like if we have 30 degrees, 45 degrees, and 60 degrees, what are the sines, cosines, and tangents, just so we can easily see what angle we're talking about. Okay, so if you remember filling this in, this can help us probably. If you put this on your paper, now I won't be able to keep it on the screen, but y'all can put it on your paper one time and then just refer to it. Which fact are we supposed to try to remember to help us get going here? Sine of 30 is a half. Okay. If sine of 30 is a half, that means the cosine of 60 is a half, right? The opposite angle, the other trig function would be a half. Then the other ones that go with this are square root of 3 over 2, so I could fill those in the sine and cosine places. And then for tangent, we always just take the sine and divide by cosine, so we would get 1 over square root of 3 for tangent of 30, but if we rationalize that denominator, that would be square root of 3 over 3. Oops, can't read it, it's so teeny tiny on here. And then for 60 degrees, it'd be square root of 3 over 1, which is square root of 3. We kind of learned that we can disregard the denominator as long as it's the same, because it would cancel out when we flip those fractions and multiply by the reciprocal. For 45, sine and cosine are square root of 2 over 2. And if you put sine over cosine there, you're just going to get 1. So these are probably going to be the ones we're going to see in this section, plus, we might get our 0 degrees, 90 degrees, pi, 3 halves pi things too showing up. Okay, so where is the cosine equal to a half over here in this little table? 60. Yeah, 60. So my angle is 60 degrees, and 60, if you said 180 divided by 3, you'd get 60, so that would be pi divided by 3, because pi and 180 are equal. So this would be x is pi thirds, which is the same as 60 degrees. It's just in radians. That was the first one we were supposed to verify up there, wasn't it? So if you think about it, cosine was positive in the first quadrant and also in the fourth quadrant, right? Because that's, if you do the all students take calculus, we can see that cosine is positive in first and 4. So for quadrant 4, you could say, well, what is 2 pi minus pi over 3? If I get a common denominator so I can actually do that subtraction, that would be multiply by 3 over 3. Wouldn't that be 6 pi over 3 minus pi over 3? And what do we get? 6 pi minus 1 pi would be 5 pi over 3, and sure enough, that's our second solution up there. So it's the same things that we've been doing about trying to figure the angle out when we've got the value. We just have to do a little rearranging on these. Now this one is there's some other types here too though. So this is, let's look at 3 I guess next. Okay, on this one of the things that confuses people is this 2x. try to ignore it until you have to deal with it. Just treat it like it was an x, okay? For just now. We'll have to think about it eventually, but the time is not now. So if it was 3 tangent squared x minus 1, and you want to get tangent by itself, we know we could, what, move the 1 to the other side by adding, right? So, and then we could divide by 3. If we do that, wouldn't we end up with tangent squared 2x is positive 1/3? Just try to skip some of that algebra on the screen. So add 1 to both sides and then divide by 3, you'd get this. All right, already I know something. I know that I'm dealing with tangent, and so I know that I should have answers in the first quadrant, and if tangent's going to be positive, in the third quadrant, right? Because that's where tangent's positive. So I've got tangent squared 2x is a third. I just want tangent x. How am I going to get just tangent x? How do we get rid of the square on the tangent? Square root. Opposite of squaring is square rooting, right? Okay. Now, we're just going to treat this like the positive 1. If you square root 1, it's 1 on top, right? And then we're going to put square root of 3. So we're just looking for the positive roots here. Unless they tell us something different, we're just going to look for the positive roots here. That would be square root of 3 over 3, right? If you rationalized it. Oops, forgot to square root it here. So tangent of 2x is square root of 3 over 3. Again, don't think about the 2x for a minute. What has a tangent of square root of 3 over 3? I'm actually going to write that down. Okay, so we're talking about a 30-degree angle, right? Okay, so that's a 30-degree angle. We know 30 degrees is pi over 6, because 180 divided by 6 would be 30. So if we substitute pi in for 180, pi divided by 6 would be 30. All right, that's, okay, now we got to think about this 2x thing going on. We're talking about the angle who has, we're talking about a 30-degree angle because it has a tangent of square root of 3 over 3, except that we don't have x here. We have 2x is equal to 30 degrees, or 2x is equal to pi over 6 if I substitute the radian measure in. Well, if it were 30 degrees, you'd know 30 degrees divided by 2 would be 15, right? Okay, here we're just going to multiply by the reciprocal, or divide by 2, which is the same thing as multiplying by a half. And we're going to get, oh, the angle I'm really talking about for x is what? Pi over 12? Okay, so you don't mess with that 2x until after you've already figured the angle out. Then you say, well, 2x is that angle, and then you just, divide both sides by 2. So we're talking about pi over 12. That would be in the first quadrant, and if you look, that's what they asked me to verify. They asked me to verify pi over 12, and sure enough, we have it, don't we? Now, they also asked me to verify 5 pi over 12, okay? Now, there's a couple of ways we could do this. Pi over 12 is a skinny little angle over here, right? Tangent is also positive over here. If I look at where this angle would be, isn't that, it's all the way out here to pi, but then we keep going pi over 12 more, right? So the other angle, this 5 pi over 12, if you look, I could say, well, it's pi plus that pi over 12 reference angle. Okay. And that would be 13 pi over 12. Is that what they asked me? Nope. Okay, let me ask you this. I've always been kind of wondered about this problem. 5 pi over 12, where would that be? Well, if you think about 12 over 12 pi would be 1 pi, right? 5 over 12 pi, half, okay, if pi is 180, half pi would be 90, right? 5 pi over 12 would be shy of 90. So on this one, oh shoot, here's what I think's going on here. If I took the square root, I'm kind of confused about this negative positive thing when you square root, because the book doesn't say anything about it. I wonder on this, if we're trying to verify 5 pi over 12, if we should check out a 30-degree reference angle, let me draw it in red, here, or a pi over 12 reference angle here. Let's see. If x is 30 degrees, what would a 30-degree reference angle here be? That would be pi minus pi over 6 would be 5 pi over 6, right? Okay, so let's try that. Maybe we do need to put a plus or minus on this. Maybe we do. Let's try it out and see if that's what's going to get us, because they're saying this is a solution and we're supposed to try to figure it out, okay? So what I'm guessing is that maybe we should put a plus or minus when we square root. We normally do that when we talk about it with like x squared equals 16. If we square root it, we normally put a plus or minus on it. So let's see if that's going to work. Let me write tangent 2x is square root of this next page. Okay, so here's what we had after we square rooted. And let's see if we have a negative. Let's say we square root and we put a negative on it. Let's see if we can get this 5 pi over 12. Let's see if we can figure out how they are saying this would be a solution. Okay, so if 2x is negative square root of 3 over 3, that could be here. So that would be pi minus 30 degrees, which would be pi minus pi over 6, would be 5 pi. Oh, this is going to do it. It would be 5 pi over 6, right? So if 2x is 5 pi over 6, and I'm going to get rid of this 2, I could divide by 2 or I could multiply by half. Do you see how that's going to give us that solution? Okay, that would be 5 pi over 12. So what did we just learn? When we square root, we need to put a plus and a minus on it. When we actually, in the solving, when we square root, I'll write it here, in the solving, I'll put if I square root, put plus or minus on the right-hand side when you square root. That's the only way we could get that 5 pi over 12 is if we did that. And it makes sense if you think about it in terms of solving quadratic equations.